Okay, so this is the 2017 scientific literacy paper. We're starting off with a fairly simple question asking you to balance an equation. So it's sodium ethanoate is used as an acidity regulator in foods. Sodium ethanoate, and it gives you the formula, can be made by reacting solutions of ethanoic acid and sodium carbonate in the laboratory. And it says write an equation for this reaction. It's 2 marks. It hasn't asked you for any state symbols. So, and it's given you most of the formulae. But what you need to realise is that because you're adding a carbonate to an acid, you're going to produce carbon dioxide and water as well as the salt that's given to you in the introduction. So if we write out that we've got, so it says sodium ethanoate can be made, so that's a product. So let's put CH3COONA as a product. And then put our arrow, and then we're saying it's made from ethanoic acid, CH3COOH, plus Na2CO3. And I've already said if we've got a carbonate and an acid, we make CO2 plus H2O. Now it's 2 marks. There's 1 for the formulae, and the second mark is going to be for the balancing. And we should be able to fairly clearly see that if we've got 2 NAs in our sodium carbonate, we're going to need to produce 2 NAs. So we're going to need to produce 2 molecules of salt. And that if I've got 2 lots of the CH3COO group, I'm going to need to have 2 moles of the ethanoic acid. Okay, moving on to question 2. It says calculate the volume in centimetres cubed of 0.5 molar Na2CO3 that would react with 25 centimetres cubed of 0.45 molar ethanoic acid. So I'm going to draw out my little table. So if we've got our carbonate, we've got our ethanoic acid, and I'm being upstaged by a cat. We need to have concentration and volume and moles, and importantly in this one, ratio, and then fill in the information it's given us. So if we know, so it says calculate the volume of 0.5 molar sodium carbonate, so we know the concentration is 0.5, and we know that the would react with 25 centimetres cubed of 0.45 ethanoic acid, and looking at the equation from above, then we know that they react 2 to 1, so there's 2 lots of acid for every 1 lot of carbonate. If you didn't get that part and you got the if you got the equation above incorrect, then the marks would follow through. Okay. So the ethanoic acid, so I need to work out how many moles of ethanoic acid I've got. So if I get my calculator, if I put in 0.45 times 25 divided by 1,000, and we come out with 0.01125. 0.01125, and then to get the moles of the carbonate I need to divide that by 2, so over 2 is 0.05625. If I want the volume then, and I've got the concentration of that, so moles is on the top, so I'm going to do moles divided by concentration. So if I divide that by 0.5, I'm going to end up with 0.01125, but that's obviously in decimeters cubed, so if I times it by 1,000, I'm going to come out with an answer of 11.25 centimetres cubed. Moving on to part B, it says the ethanoate ion forms an alkaline solution in water. Write an equation to show this. So if we write the formula for the ethanoate ion, which is CH3COO minus, and if we have that reacting with water, which is plus H2O, we know that it's going to form alkaline solution. So an alkaline solution would suggest we've got some hydroxide ions in there. So if this is going to be an equilibrium, I think in the mark scheme it doesn't matter if you put an equilibrium sign or an arrow, but for this it would form an equilibrium. We're going to get CH3COOH because it's going to accept a proton from the water plus OH minus. No need for any state symbols, it's only 1 mark. You've then, in the next one, got a very similar equation. So it says ethanoic acid is a weak acid. Write an equation for the reaction of ethanoic acid in water. So if we write that we've got CH3COOH, and we're going to add H2O. Now, it's told you it's a weak acid, so we know that it's really important this time that we're going to use our equilibrium sign because weak acids form equilibria. So if we then this time our water is going to be our proton acceptor, so and our ethanoic acid is going to be the proton donor. So what we're going to do is we're going to form that ethanoate ion and H3O plus. Okay, then we move on to a fairly simple, straightforward pH calculation. So we're asked to calculate the pH of the weak acid. So if we remember that Ka is equal to our hydrogen ion concentration, and remember we can say it's squared because it would be H plus and A minus, and because H plus and A minus are the same, we can say it's H plus squared. Divided by the concentration of HA, which we can assume is the initial concentration of the acid at the start of the experiment, or at the start, the initial concentration. I can then say that I can rearrange this to show me that H plus concentration is going to be equal to Ka times HA. And I'm going to have to square root it because I've got H plus squared up here and I want it just as H plus. So if I fill in the numbers, I can then get that H plus concentration is going to be equal to Ka, which is 1.7 times 10 to the minus 5, times the concentration, which is 0.030, and the square root of that. So if I get my calculator and I put in 1.7 exponent minus 5 times 0.03 is equal to that. If I square root that, then I know I've got my hydrogen ion concentration is 0.00714. And then to get from the hydrogen ion concentration to the pH, I need to remember that pH is equal to negative log of the hydrogen ion concentration, 0.00714. So if I do log of that, I get an answer that's minus 3.14, but I know that I'm taking the negative of that, so the pH is 3.15. Okay, and that's your 2 marks.